Hello, welcome back to our video series on healthcare information technology. In this video, we'll discuss chapter number 6, Document Imaging and Problem Solving. Some objectives for this chapter: describe frequently used healthcare image file types and their characteristics, identify medical interface components, explain the interface diagnosis process, describe the clinical software troubleshooting process, explain the need for and use of change control in the clinical environment. According to recent studies, fewer than 2% of hospitals employ a comprehensive electronic health record system, or EHR system. And there are some big challenges that come with the integration of an EHR system, and one of which is the interfacing of dissimilar systems. For example, X-rays can produce an image on cellulose or on polyester film, so those film images must be digitized. So that's going to add an investment of more time by the staff to get everything on an electronic system. Or the X-ray machine has to be modified to output a digital image. So either one of those will lead to an increase in time, increase in money. Next we'll talk about document imaging. Now, images must be organized into a standardized format for storage. And image files can be composed of pixels, which are small picture elements, bitmap data, vector data, geometric data, or a combination of these data types. Now when it comes to file types, there are different applications for image files, and the reason why we have different kinds of image file types. And they will vary in their characteristics, and these differences are based on quality of the image, size, resolution, and compression of the image files. When we talk about image quality, this is describing how well the image file maintains fidelity of the source image, or how true is the image to the object that's being taken the picture of. And high quality images appear more like the source than low quality. File size, this is describing the number of bytes needed to store that data file. Compression is a technique used to reduce the size of a digital image file. The more you're able to compress larger files, the more files you're able to store effectively. Image resolution, this refers to the number of pixels in an image. It is typically stated by the number of pixels high by the number of pixels wide, so length times width. And multiplying the pixel counts will give a single resolution number. For example, a digital camera that has a resolution of 2048 pixels high by 1536 pixels wide. If you multiply these two values together, you get a value over 3.1 million pixels. So that is equivalent to 3 megapixels. The prefix mega is a reference to million, so 3 million pixels. And there are 4 image types that are commonly used in healthcare. You have the GIF, the GIF, the graphics interchange format. You have the JPEG, JPG or JPEG, Joint Photographic Experts Group, PDF, the portable document format, and the TIFF, TIFF, the tagged image file format. Alright, in this table we have a comparison of the 4 types we just mentioned: GIF, JPEG, PDF, and TIFF, the quality of the image that they take, the file size that will result in that image, the resolution of the image, and the compression. So the smallest file size of these 4 will be the GIF. You may only get a resolution of only 8 bits, which leads to a small file size, but the quality of the image will be low. The step up from that would be a JPEG. You have a medium quality of the image. A file size is still relatively small, but you get much more of resolution compared to a GIF. You get 24 bits. A step up from that, PDF, high quality, but the file size will be much larger. That's due to the resolution being better than the previous 2 types. You get 64 bits resolution. And same thing goes for a TIFF file. High quality of image, but a very large file size due to the increased resolution. Next we'll talk about scanning and indexing. Now, storing an image file in a data file is a key part of creating an electronic document storage and retrieval system. Being able to identify what a picture is, what test was it taken from, the date it was taken, and what patient does it belong to, and so on. A typical hospital can create hundreds to even thousands of images per day. And when it comes to scanning, it's the process of converting a paper-based data into an electronic format. In this image we have a pretty typical example of a desktop scanner. The information would go in here to be scanned, to be stored in an electronic version, such as the patient's driver's license or their insurance information. Instead of having someone type in all those changes or type in the data that would be on that piece of paper, scanning it in and saving it as a PDF for faster retrieval. And an electronic file is considered to be protected health information. because you're dealing with someone's personal, private information, so it must be protected. And with electronic information, you get metadata. And this is the data that's used to describe the attributes of the image. So this could be the date that the file was created, the patient ID, hospital name, and so on. And the data is included with the image file. And this can vary greatly depending on the application being used, how that data is used, and any applicable regulations. Storage of these images. This refers to the process of saving data for future retrieval and use. A database is a structure used to store data. And then an index. This is a data structure that allows for fast data retrieval. Next we'll talk about OCR and structured data. OCR is optical character recognition. And structured data is when data is arranged in a very defined manner. And unstructured data has no predefined arrangement, such as audio files or text files or bitmap images. And then OCR, the optical character recognition, is a process of converting scanned images of handwritten or printed text into computer-readable text. So being able to scan a copy of someone's driver's license or their health insurance information, being able to scan it and have that data be converted into electronic information right away, as opposed to having someone type in all that information. Now we'll talk about medical interface components. And one we'll talk about is HL7, Health Level 7. This is a non-profit accredited standards development organization. And this will develop standard languages for formatting electronic messages between healthcare providers. And messages that are exchanged with HL7 have a pretty similar message components. And the segments are presented in a defined sequence. And the segments may be optional or required or repeatable. And here we have an example of how a HL7 message may look. In the message header segment up here at the very top, the event type here, the patient information segment here, a patient demographic segment, and patient visit segment. So here's how a HL7 message could look, with the message segment up here, the event segment here, the patient ID. As you skim through this, you can see patient's name would be here, the address here, and the last two segments here, the demographic information and patient visit information, are left blank on this message. In this last block here, the patient visit, if the patient were to have any test ordered, that would be listed here. So it's a standardized way to exchange information from various healthcare providers regarding the same patient. And there are some commonly used HL7 message types. You have a general acknowledgement, or the ACK, the ADT, admit, discharge, or transfer, the BAR, either adding or changing the billing amount, DFT, a detailed financial transaction. And regarding this message type, ADT, the patient being admitted, discharged, or transferred, there are some example message subtypes: AO1, AO2, AO3, AO4. AO1 will be the patient admit, AO2 will be the patient transfer, AO3 patient discharge, AO4 patient registration. So going back to our sample image we talked about a second ago. Here on the second group, the EVN, the event type. Subtype here, AO1, that's an indicator of when this patient was admitted. And all HL7 messages will have some pretty standard segment contents. Those would include the message header, the software segment, the event type, and then the patient ID. Alright, in this table we have some common HL7 message segments. Their description in this column, the code, and then some notes about each one. So for example, a patient allergy information segment would be coded as AL1. Billing segment, BLG. Insurance information, IN1. So all these that are listed here, fairly common segments to a standard HL7 message. Alright, now we'll talk about E-Prescribing. This is the electronic transmission of a prescription to a pharmacy from the point of care. So instead of having a physician write out a traditional prescription on a piece of paper and having that patient take it to their pharmacist, it can be basically emailed to the pharmacy directly. And this can lower the cost of medication transactions, and also can be used to improve management of traditional medication administration problems. And this can also help with medication reconciliation. And this is the process of avoiding medication inconsistencies across care settings. So what this basically means is having the most accurate and up-to-date list of whatever medications that patient is taking, especially if a patient sees multiple doctors at multiple facilities. They may forget what kind of drug they're taking, or what the dosage is, or how often they take it. So if this is done electronically, there's always a record of what drug was ordered, what the dosage is, what the frequency is. And this can be accomplished with a process integrated with an EMR, electronic medical record. Next we'll talk about BMV, the bedside medication verification. This is the method of verifying correct medications are administered to the right patient. This is commonly accomplished with barcodes and a barcode scanner. And this is why if you are admitted to a hospital, whenever you are about to be given medication, you're asked to confirm your name, your birth date, why you're there, so they can confirm they are giving the right drug to the right patient. And this is also why they may scan your admin bracelet to confirm electronically you are who you say you are. So next topic, DAI, drug allergy interactions. Now certain drugs or certain drug combinations can cause allergic reactions in some patients. So it's very helpful to maintain an accurate database of patient allergy list. So maintaining this database may be accomplished using the CPOE system, the computerized physician order entry. The formulary is a list of medications that is covered by a third-party payer. And the formulary checking is a part of the e-prescribing process. This process will verify that any medications that are prescribed are actually in the formulary. Alright, now we'll talk about billing. The medical information from the provider's electronic medical or electronic health record is used to create an electronic version of the patient's bill. And this will be then transmitted to a third-party payer. And this will be done through within an HL7 message. Some common HL7 billing segments that you'll find: the PID, the patient identification; PV1, the visit information; FT1, financial transaction; IN1, insurance information; IN2 and IN3, any additional insurance information; the GT1, the guarantor; and then the AUT authorization information. From here, the bill may be sent to a billing clearinghouse, and this will validate the claims to ensure that the bill is free of any errors. Then the bill will be transmitted to a specific payer over a secure connection. Our next topic we'll talk about is diagnosing interface problems. And when you have any kind of problem like this, what you're really doing is troubleshooting. This is the systematic approach to determine the source of the problem. And there are 4 troubleshooting steps. You have identification, generation, determination, and confirmation. First we'll start with HL7 message problems. And there are some common problems that will pop up with HL7 messages, such as improperly formatted patient demographics. An example, if the patient's social security number is 123456789, but it's typed in as 1234T, and that could easily happen because the letter T is just below the number 5 on a standard keyboard. So common mistyping errors. You also have errors with communication links generated as a result of a failure within a fax or within a network or in an internet connection. And this is more common in areas with an aging communications infrastructure or an area that has frequent power interruptions. Some problems that can come up with e-prescribing is inaccurate patient demographics, where the patient medical history may be inaccurate. But that's just one of a variety of multiple causes that could come up with inaccurate demographics. And there is a national standard that's used for e-prescribing, and it was developed by the NCPDP, National Council for Prescription Drug Programs. And this organization has also developed the script standard, or what establishes standards in e-prescribing messaging, including what fields will be used and what segments will be used. In this image we have an example of how a script message would look. The pharmacy that the message was sent to, the patient, the drug that was prescribed, and the directions. When it comes to billing problems, a form that's typically used by providers is something called the super bill. This is a form used by providers to quickly list the patient's procedures, diagnosis for reimbursement, any services rendered to that patient. This is commonly adapted for a specific provider, and information on here could include patient demographic data, CPT procedure codes, and ICD diagnostic codes. This may cause errors if the data is inconsistent with other data. Some other problems that could come up with billing is the configuration of the billing software. And some examples of some configuration errors: should you bill patient for missed copays? Do you display the diagnosis description? Do you display the procedure description? Or the rendering provider, or the scheduling provider, or the service location, or the supervising provider? And some configuration settings are important for accurate data transmission. Next we'll talk about medical device problems. Okay, what happens when medical devices either aren't working properly or aren't working at all, and how do you troubleshoot what may be going on? The first one is to check the power first, obviously. Is it plugged in or not? Is there power getting to the device? Brownouts or voltage sags may cause medical device interface issues. Some less common power problems with medical devices: blackouts or spikes or surges or electrical noise. So it is advise that you would use a UPS, uninterruptible power supply, on the device or on a central power system. On this table we have a description of some of the less common power problems. The problem type here, blackout, spikes, surges, noise, and how you may potentially solve that problem. So for example, a blackout is a total loss of power, and the way you may get around that problem would be using a UPS. Spikes is a very short duration of voltage increase. So the way you could get around that would be have a surge arrestor at the main breaker panel or a surge suppressor at the device. It surges. This is a short duration of a voltage increase. Same potential solutions for the spikes, having a surge arrestor at the main breaker panel or a surge suppressor to be used. And the last one here, electrical noise. This is unwanted high frequency energy, and the potential solution for that would be to shield the source or having a line filter. Some other problems that could come up with medical devices: having network or communication problems. And having a failure in the network can cause data corruption. And some devices can be configured to perform differently by adjusting their configuration settings. Now we'll talk about troubleshooting clinical software problems. There are a variety of different kinds of clinical software, including auditing systems, billing systems, coding, CPOEs, electronic medical record or electronic health record systems, lab information systems, patient care planning systems, pharmacy information systems, patient tracking, patient scheduling, radiology information, and workflow management. And there must be a defined plan for troubleshooting any software system that is integrated. So this is imperative for the healthcare IT professional. When it comes to the troubleshooting process, you need to locate the affected modules or the affected fields. You need to be able to identify the system malfunctions or list their possible causes, determine the cause of the problem, and then develop and test the solution. And finally confirm that the problem has been solved. The approach for the first step is to divide the problem into smaller domains, and then work backward in the system from where the problem appears. So once you figure out what's wrong, how could it have gotten to that point when things went wrong? That's why you work backwards. When it comes to determining the data type, you need to determine the data type error. And data is classified based on its properties, whether it be text or numeric or binary. And database and software applications expect data to be of a certain type. So you need to check the configuration to ensure that the user inputs have been checked for correct data types. And manual configuration changes may have allowed errors to be introduced into the system. When a software problem can't be solved through normal troubleshooting methods, you may need to escalate to another technical support group. And there should be a process that describes who should be contacted first if a problem does need to be escalated. And technical support groups are often organized into tiers. So the initial call to support group will encounter Tier 1 support. And if they can't handle it or can't figure out what's going on, that would escalate to Tier 2. On this table we have a brief description of the various tiers and what they would do. So for Tier 1, collecting customer information, providing very basic support for very simple problems. If that escalates, it goes to Tier 2, more in-depth support from staff with more experience and more knowledge. As that escalates, it goes to Tier 3. This is usually the highest level of support. It may involve staff that's capable of working directly with the software designers. Then in very rare cases, it goes to Tier 4, which will provide direct access to the software designers themselves. All right, now we'll talk about change control. So clinical software modules are often used together in an integrated system. So this will increase the overall system complexity exponentially. And software will regularly change over time. So this will usually lead to new requirements and regulations. So bug fixes or performance improvements are needed to make sure that the software is working at an optimal level. And when it comes to a change control system, this is a procedure for systematic software customization. And there are specifics that are required for a change control system, such as change compliance reporting, defining specific change process activities, delineating testing and cutover processes, developing a change schedule, identifying the impacts of change, and specifying staff roles regarding the change control. Now the risk and the cost of failure with software change may be quite high. So this goes to governance, which is the alignment around objectives, strategies, and tools and methods to minimize the change failure. And the group that is charged with the responsibility to approve changes that may result in a critical service interruption is a CMGB, the Change Management Governance Board. When it comes to system patching and updates, there are different kinds of software changes. A patch is a fix for a specific software problem, and an update includes larger changes relative to those of patches. And these can add features to the software or functionality to the software. And these are usually issued less frequently than patches, because you're dealing with more changes to the software. When it comes to change scheduling, this can be very challenging in a highly integrated environment. Now, some clinical software systems are used around the clock every day of the year. So you can imagine when you need to update software for an entire network in a major hospital, the software is going to be down while you're updating the software. Now, some questions should come up when you talk about change scheduling. Is there a backup system in case something goes wrong with the updating? Can collected data be recovered during the system downtime? Will the downtime impact any life support systems? Were all impacted departments notified, and did they approve the proposed schedule? If you're going to have services unavailable to a department, they need to be notified ahead of time, not as you're turning the software off. Can the old system be rolled back if the updates are not functional? So the answers to these questions will affect the update schedule. When it comes to change control environments, there are 4 stages in the software change process. You have development, quality assurance test, user test, and then production. Development is the actual writing of the new program code to address the needs. The QA test, or quality assurance test, this ensures that the software meets functional requirements and defined performance behaviors. The user test, assessing whether or not the software meets user requirements. And then production, or making the software live, where the software is released to be used in a real live environment. Alright, that brings us to the end of this chapter. A quick summary of what we've covered. Images must be organized into a standard format for storage. Scanning is a process of converting printed data into electronic format. Data can be classified as either structured or unstructured. For information to be shared, a common language or format must be used. Health Level 7 is a standards development organization. An HL7 message is composed of groups of message segments presented in a predefined sequence. Troubleshooting uses a systemic approach to determine the source of a problem. And software regularly changes over time, which will increase the complexity of clinical software management. This is where you need to have change control processes needed. Okay. That brings us to the end of this video for chapter number 6. We will continue our video series on healthcare information technology with our next video on chapter number 7, Basic Healthcare Information Security.